10-9-8-765-43-210 ignition, liftoff.
Rockets are really impressive. But how do they work? How are they started? Does someone control them? How do they work in space? How do they slow down in space? And maybe the most important thing, if something goes wrong, could they fall on someone's house? Let's understand all of this in this video. Launch team, please remain at your consoles. The principle behind how a rocket works is based on Newton's third law, which states that for every action, there is an equal and opposite reaction with equal magnitude along the same line, but in the opposite direction.
In this way, the gases expelled by the engines at high temperatures, pressure, and speed exert a force. And as a reaction, the rocket moves in the opposite direction, in this case upward. But how does this work in practice? In a rocket engine, here's what happens. When combustion occurs inside the chamber, the burning of the fuel will cause the gases to expand in all directions, exerting force on the walls of the engine. The gas molecules that hit the side wall of the engine will exert a force, but it won't produce thrust, since the force exerted on one side will cancel out the force on the other. But the pressure exerted on the top of the chamber will produce thrust, since there is no pressure exerted on the bottom of the engine to cancel out this force. In this way,
the rocket rises in response to the gases expelled from its engine, and that's why this type of engine is called reaction propulsion. Rockets use propellant to generate thrust, and they are usually powered by liquid propellant, solid propellant, or both. The combination of an oxidizer, like oxygen, and a fuel, like hydrogen, is called propellant. Rockets carry with them all the fuel needed for the mission they intend to carry out. And in the case of liquid-fueled rockets, this fuel is stored in two different tanks. One for the oxidizer, which is liquid oxygen, and another for the fuel, which is usually liquid hydrogen. A question that may come up is, why are oxygen and hydrogen used in their liquid state? The reason for this is that the volume of 1 liter of oxygen in liquid form is approximately equal to that of 860 liters of gaseous oxygen. In other words, 1 liter of liquid oxygen occupies a much smaller volume and contains a higher concentration of oxygen than the same amount in the gaseous state. Liquid oxygen is extracted from atmospheric air through a process called fractional liquefaction. And oxygen needs to be at a temperature of minus 182 degrees Celsius to become liquid, and hydrogen at minus 253 degrees Celsius to become liquid. That's why we see that white smoke during rocket launches. Another interesting fact is that the fuel is also used to cool the engine. It passes through these tubes and also through smaller tubes inside the engine, cooling the engine and preheating the fuel before combustion, increasing power and improving engine performance.
5, 3, 2, 1, 0. And the glide of the spaceplane Atlantis with the mission to build cooling.
on the other hand,
solid propellant rockets produce the most thrust. But once ignited, they can't be turned off and remain operational until their fuel is completely depleted. Solid propellant rockets use aluminum powder as fuel and a mineral salt, ammonium perchlorate, as the oxidizer. Generally, solid propellant rockets are used on the sides of rockets, functioning as boosters and providing extra thrust to the rocket during the initial moments of launch, when the rocket is at its heaviest. Okay, but there has to be some way to ignite these engines. So, how are they ignited? In the case of liquid-fueled rockets, like SpaceX's Falcon 9 hypergolic ignition is used, which happens when two substances spontaneously catch fire upon contact with each other, without needing a spark or external heat source. These substances are triethyl aluminum and triethylborane, also known as TTB. TTEB ignites instantly as soon as it comes into contact with oxygen, which can be from the surrounding air or from the liquid oxygen stored in the facility's tank. And that's why we see that green flash just before the engines ignite. That flash is caused by the presence of boron in TTEB. In the case of the space shuttles, they used pyrotechnic ignition, which relied on a spark-generating device called a spark igniter, which produced a huge amount of sparks needed to ignite the vehicle's three main engines. Other rockets, like the European Ariane 5, used two small solid fuel motors to ignite the main engine.
Even EAB ignition. Liftoff.
What if something goes wrong with the rocket? Could it fall on someone's house? That this is possible and has already happened. The probability of this happening is very low, since rockets operate under what's called range safety, which is a set of measures that ensures the protection of people as well as infrastructure located within a perimeter that could be affected in case of a serious rocket failure. For a rocket that is out of control, the team responsible can command the shutdown of the rocket's propulsion system, or in more serious cases use the independent flight termination system, which has transceivers to receive the command to self-destruct. Okay, now that we know how rockets work and that they are safe, how do they work in space? If there's no matter there, it's just a vacuum. How is that possible? As we saw before, rockets carry all the fuel they need to sustain the burning of the propellant in the rocket's combustion chamber, and that such fuel is stored in the rocket's fuel tanks, including the liquid oxygen, enough to allow the engines to operate until their mission is completed. Once in space, the rocket engines will function normally, even though there is no oxygen there to support propellant combustion in the engine's combustion chamber. That's because rockets already carry with them all the necessary elements for the rocket and its engines to function in space. And as we've seen before, rockets can also restart their engines in the vacuum of space by using hypergolic ignition as many times as needed. Okay, but how do they slow down in space if there is no air there? According to Newton's first law, which states that an object will remain at rest or in uniform motion in a straight line unless its state is changed by forces applied to it. So, once in space, if the engines are turned off, the rocket will keep moving in the same direction forever, since there's no air in space to slow it down or make it change course. To slow down the rocket and make it re-enter the atmosphere, it's necessary to apply a force in the opposite direction of its movement. That is, if the rocket is moving forward, it needs to reorient itself and put the back where the engines are in front. That way, the engines can be turned on, but this time to slow the vehicle down instead of speeding it up. In the case of the space shuttles, a system called the reaction control system was responsible for changing the orientation of the spacecraft. It did this by firing small jets, changing the orientation of the spacecraft and putting it in any position that was needed. That way, the space shuttle could reorient itself and put its engines in front, and turn them on to slow down the spacecraft.